Okay, picture this. You're in a big building, right? An office, a hospital, maybe a shopping mall, and boom, everything goes dark. The power's out. In that kind of confusing moment, a set of emergency lights kick on, guiding you to safety. But have you ever actually stopped to wonder what's keeping those lights on?
I mean, it seems like a simple question, doesn't it? But the answer, well, it's this really cool piece of engineering that most of us probably walk past every single day and don't even notice. And spoiler alert, it's not just a little battery stuffed inside each light.
Nope, it's way bigger than that. It's this centralized, super robust system. You could almost call it the building's hidden hero. It's designed to be that last line of defense when, everything else has gone wrong.
All right, so let's pull back the curtain and meet this hidden hero. We're talking about central battery systems. The easiest way to think about it, it's like a building's own private mini power grid just for emergencies.
And, the real genius of this whole setup is how simple it is, really. Instead of every single emergency light having its own little battery that could fail, everything is pulled together in one place. You've got one central cabinet, usually tucked away somewhere safe, and that's where you'll find the power, the charger, the controls, the whole shebang for the entire network.
This is a great way to look at it. You've got the brain, that's the central cabinet. Then you have the nerves. These are really important. They're special fire-protected cables that make sure the power keeps flowing, even if there's a fire. And then you've got the eyes, the lights themselves, what they call slave luminaires. That's what you actually see lighting your way. It's a simple, tough, and frankly brilliant design.
Okay, so now that we've got the basics down, let's get into the first really big decision you have to make with these systems. Are you going to go with AC or DC? And believe me, this isn't just some nerdy technical detail. This choice, it changes everything about what the system is capable of.
And you can really see the trade-off here. AC systems, they're all about raw power. You can use standard light fittings, which means you can get much brighter emergency light. But DC systems, they're the marathon runners of the group. We're talking crazy long battery life, up to 25 years in some cases. Plus, you get a ton more options for monitoring the whole thing.
So yeah, AC versus DC, that's a huge decision. But it kind of leads us to an even more critical piece of the puzzle, the battery itself. Let's dig into what's actually powering this thing from inside that central cabinet.
Because let's be real, not all batteries are created equal, right? The type you choose here is going to directly impact the cost, how long the system lasts, and how much work it is to maintain.
This chart really lays it all out for us. It's that classic engineering problem, the triangle between cost, lifespan, and maintenance. On one end, you've got your entry-level sealed lead acid. Low upfront cost, pretty low maintenance, but it's not going to last as long. On the other end of the spectrum, you can go all out with vented nickel cadmium. This thing can last up to 25 years, but it's going to cost you a lot more at the start, and it needs a lot more attention.
And of course, each one has its own little quirks. You can't let those sealed lead acid batteries run all the way down, or they're toast. The vented types are big, they're heavy, and a lot of the time they need their own dedicated ventilated room. So the big takeaway here is that there's no one-size-fits-all best battery. It's all about finding the right fit for the building's needs and, of course, its budget.
So with all these options and things to think about, you might be asking yourself, why even bother? Why not just stick a little battery in every single light and call it a day? And the answer is pretty simple, actually. The payoff is, well, it's massive.
25. Just think about that number for a second. 25 years. That's the potential lifespan we're talking about for these batteries. And to put that into perspective for you, the little batteries you find in your typical self-contained emergency lights, you're lucky to get 4 years out of them. So we're talking more than 6 times the lifespan. The long-term savings alone are just huge.
And this really brings it all home. The total cost of ownership just plummets because you're not running around replacing dozens of batteries every few years. Maintenance becomes so much easier. One person, one spot, and the whole system is tested. They're way more reliable, especially in tricky environments like hot boiler rooms. And they can power much brighter, more effective lights. For anyone who owns or manages a building, this is all about peace of mind. It's safer, it's cheaper over the long haul, and it's just so much easier to handle.
So the next time you're somewhere and the power cuts out and those emergency lights pop on, you'll know what's going on. You'll know about that hidden hero working behind the scenes. And it really makes you think, doesn't it? What other invisible systems are out there all around us, just quietly doing their job to keep us safe every single day?